I am Arjun. In this session, we'll see the problems related to trusses. So the given problem is for the truss element loaded as shown in figure, determine nodal displacements, element stresses, and reactions it supports. Given area 1, area of element 1 is 1200 mm square and area of element 2 is 1000 mm square. Young's modulus for element 1 and element 2 are same, which is 200 GPa, and the material is loaded in y direction at node 2 with 50 kilonewton. Okay, now we'll solve this problem using Ansys. The version is 14.0. I'll go to preferences, select structural analysis. Okay, preprocessor, element type, add element, add. So we'll select link element because the truss will be created using link elements. Link. Okay. Close this. Now we need to set real constants. Now we have to be very careful here. Here we have two elements, so we need to set real constants for both elements. Real constants. Add. Click on add. So now the link will be, which I have created, will come to here. Click on OK. So now real constants at number 1, we have two elements. So this is for element 1, area is 1200 mm square. So I'll enter 1200 mm square. Okay, you can click on OK or you can click on apply. So I'll click on apply. So now so you can see here set 1 is created. For element 1, area is 1200, which is created. And now I'll select element 2, set 2, and for element 2 area is 1000 mm square. So I'll select 1000 mm square. Now if I click on OK, this command menu will be closed. Okay, so you can observe here set 1, set 2. So you have to be careful here because we have two different element properties with two different set of real constants. That is cross-sectional areas for element 1 is different and element 2 is different. Okay, now close it. Go to material properties, material models, structural, linear, elastic, isotropic. So since Young's modulus is same for both the elements, so 200 e power 3, Poisson's ratio is 0.3. Okay, and if it is different, in case in the problem if the element properties are different, again you can go to material, new model, you can select ID number 2, and again you can say enter the other material properties given. So for this case, since the element property is same, it is not required. Okay, now we can close this. Go to modeling, create. So either you can create a truss element or the links using either key points or nodes. Okay, so if you create using key points, you need to mesh. So in order to overcome that difficulty, I'll create that elements using nodes. So nodes in active coordinate system. Now node number 1, the coordinates are 0, 0. So x, this stands for x, this stands for y, this stands for z. So x is 0, y is 0. Okay, click on apply. So you can see here node 1 will be created here, and now change this to node number 2. So for node number 2, x coordinate is 750 and y coordinate is 500. Click on apply. See, node 2 will be created somewhere around here, and node 3, x coordinate is 0 and y coordinate is 500. If you click on OK, so you can observe 3 nodes which have been created. So this is node 1, node 2, node 3. So since we have created nodes, we need to create elements. Okay, so now you have to be very careful while creating elements because two elements are there and each element cross-sectional area is different. So first go to elements, go to element attributes. See here, if the material properties are different, if you click on here, okay, on the scroll down you will get two different material properties which you have defined. See, now we have two set of real constants that we have defined in the beginning. So you can see that here. So real constant set number 1 and real constant set number 2. Since we are creating element 1, I'll select real constant set number 1 and material number 1. If in case if two different materials are there, again at that time you need to select both of them very carefully. Click on OK. Then come to elements, auto number through nodes. That means to say we are creating element through nodes. So select node 1, node 2, click on OK. Now element 1 is created with real constant set number 1. Again, in order to create element 2, we should go to element attributes. Okay. Here now change the real constant set number 2, which automatically takes the cross-sectional area as 1000 mm square. Click on OK. Now auto number through nodes. Now you have to create element 2 using node 2 and node 3. Click on OK. So now this element 1 is with the cross-sectional area 1200 and element 2 is with the cross-sectional area 1000 mm square. Okay. Now it has been modeled. You can directly apply loads, define loads, apply structural displacement on nodes. So select node 1 and node 3. So you can fix this in all degrees of freedom because it is totally constrained. Okay, and we need to apply force at this point. Each node having 2 degrees of freedom. Remember, this is a 2-dimensional member truss. So force or moment on node. Select node 2. Apply. The load will be acting in y direction. And the load value is 50 kilonewton. So it will be minus 50,000 because all the load values will be taken in terms of newtons. So you can observe here how it is. The material is loaded. Go to solution. Now we can solve the problem. Solution, solve, current load step. So now the problem is solved. So we need to find out the nodal displacements. So in order to find out the nodal displacements and in order to view the element stresses, we need to define the table. Go to element table, define table, add. So scroll this down, ls1 for defining stress. Okay. And similarly for defining strain, LEPL1. Okay, close it. And so now go to plot results, go to contour plot, nodal solution, DOF solution, displacement vector sum. So these are the maximum displacements. And if you want to see the each and individual nodal solution, go to list results, nodal solution, DOF solution, displacement vector sum. So you can see, this is, we have 3 nodes, node 1, node 2, node 3. Since node 1 is totally fixed, so this is Q1. This is Q1, which is 0. Node 1 is fixed in y direction, so Q2 it is 0. This is Q3, value of Q3 is 0.28125. Value of Q4 is minus 1.0322. So this is Q4 and Q5 and Q6. Since node 3 is fixed, this value will be 0. So you can keep this as it is. And I'll take this table. And if you want to see the reaction solution, go to reaction solutions, reaction forces, all structural force. Click on OK. Now these are the reaction forces. See, reactions will be obtained only at the fixed ends. That is the reason why we call it as reactions at supports. So you can see node 1 and node 3 is fixed. So the total force is, what we have applied is minus 50,000 and the reaction is opposite to minus 50, so which is plus 50,000. And if you want to see the stresses, go to plot results, contour plot, line element. So LS1 and LS1, these are the values of stresses. And if you want to view it in a table, go to list results, element table data. You can select stress and strain here. Click on OK. So these are the values of stresses for element 1. Okay, stress is minus 75.116. For element 2, stress is plus 75. For element 1 strain is minus 0.375 into 10 power minus 3. For element 2, 0.375 into 10 power minus 3. So these are the result tables which you can cross check with the analytical solutions. Thank you.